So, hi, Steve. I just look at your blog and I found out that you actually started pre-Java, so Java before Java. How it is possible, actually?
Yeah, I started Java when it was in alpha version 1.0 alpha. So uh, I was doing development work in a weather company, and they were looking at how to display weather maps online, which in the very early days in the sort of 1990s. And we came across Java, and we sort of messed around with Java applets to try and display interactively complex sort of weather maps for pilots and things like that. So I played with Java then and been using it ever since, to be honest.
And did it actually work with your weather maps?
No, it didn't really work. Didn't really work at all. But it was in the days of applets where it was just sort of dancing Duke. We could put some image tiling in there. They didn't go that way in the end, but it was a good experiment. And from that day onwards, we actually worked with Java and moved over from C++ to Java for mainly back-end server coding. So we carried on with Java, but the applet never materialized.
So what I remember from these days it was the Duke with the air hammer, or how it's called, the industrial air pressure hammer, and it was on a very famous applet. What I'm curious about, were you just able to download Java pre without any big deal from Javasoft directly? So you could just download alpha and it worked?
Yeah, it's a long time ago. I think you could just download it. It was always freely available to use. Maybe it might have had a potential commercial license. I can't remember. But at the time where we were experimenting, it was free to use. There was no IDE support, obviously, so it was all done in sort of Emacs at the time. And the class path was a nightmare to get your head around because you had no support for it. So you had to set all the environment variables up correctly and everything. But it was good. I mean, at the time I was a C++ programmer, so the benefit of Java at that time over C++ was just the huge amounts of standard libraries within Java itself, like threading and networking, which was a horrible thing to do in C++ cross-platform.
Exactly. So we had almost the same history. So I started with C++, and someone mentioned like Java is the real thing, and I really like C++. And I said, okay, if it's the case, I just switched to Java, and I downloaded from Javasoft also a pre-version, and I started with applets, and I couldn't get the point. Why we need applets? Like, what's the deal with that? But a few months later, I got asked, questions whether I could program something on the server with content management system. And I got the idea to use Java because I had no idea about CGI back then. So I stick with Java from then. Okay, nice. So a couple of years later, so I tried to remember how we actually met the first time. And what I found is an email from 2014 where you invited me to have a virtual Java user group session. And I delivered a session about Glassfish V4 monitoring. And I think at the same year, per accident, I signed up to a session, Java 1 session, and you delivered a session, and I think it was about JMS and JCA or stuff like that. So back then, it was C2B2, I think, the company, yep. And then you found Payara. So what interests me, what was your way, to Java E? So how it happened and why you started with Java E at all? Because if you are from the early days, you could do something else. So why what is your road to Java E?
So Java EE, I've done Java EE since the late 90s, really. So in the 90s, I worked for a company called Object Design, which was an object database company. They had a C++-based object database, which was very clever technology. But they also had a Java-based one, and people at that time were moving from Perl and CGI over to servlets. So my first experience really in Java EE was the servlet specification and looking at building web applications using servlets, because at the time, very much like serverless in this day and age, CGI scripts had a problem where they weren't resident. They just fired up when you accessed the CGI script. Whereas servlets were resident in memory in an application server. So we used to use JRun. We used to build a lot of web applications. Well, our companies were building a lot of web applications at that time, and it was all the latest technology. So we were using Java servlets, accessing object databases. This is before the days of JPA, or even before EJB, really. So I can remember when EJB Container Managed Persistent came out, that we, as an object database company, we laughed at the specification. And if you go back in time at those days, there was a competing specification called Java Data Objects, which was very much more like JPA is nowadays. And we had some experimental support to Java Data Objects. So that's basically where I came in from into Java EE, because everyone in the 90s was building new web applications, and they were playing with object databases as well for storing media and those things that you couldn't at the time store in relational databases.
The object design, was it Object Store?
It was Object Store, yeah.
Okay.
So I was an Object Store consultant at the time.
Oh, very interesting. And I evaluated Object Store for a company back then. So because the object databases were the thing, and we had to store industrial data. So there's another similarity. It's really funny. So an Object Store, and there was a thing renamed to Echelon or something like this later then, right?
I was at Echelon when they renamed, yeah. It basically, company changed its name to Echelon, and they had an XML database at the time, which was based on Object Store.
Mm-hmm. And actually, there was Java JDO, there was CMP, and there was a commercial product. I forgot the name from Sun. It was very similar to object databases. I forget actually the name. I have to look it up.
It was also TopLink at the time, which has now become Eclipse Link.
This was Smalltalk, right? This was in Smalltalk, and there was I have to look it up. So I dig into this. There was a commercial product was very similar to JDO, and it was actually funny that Sun had two competing standards like JDO and CMP, and both were completely different. Where JDO was like JPA and CMP was like, how to call it? It would be more like almost serverless technology, where the persistent object had a remote view as well. So it was like interesting approach, which actually never worked, right? Because the next spec they removed the remote.
Yeah.
Okay. And so you stick with that, and then you used EJB in one point of time, or what was the road, to Glassfish, or? Yeah,
I mean, we used, they say object design at the time tended to be heavily used in web applications. Mm-hmm. So we used EJB, we used servlets, we used remote EJBs. As at the time, there was a lot of work with RMI and building distributed systems, or N-tier systems as they were called at the time, which is very similar to a microservices architecture now, whereby you had little services that talk to each other, which hence it was N-tier, because we had many different tiers of the architecture. And that was tended to be built in RMI. And then EJB was basically invented to solve the problems of RMI, from my perspective. So we worked with EJB. We worked across, because I was a technology consultant, I worked all over Europe in many, many different projects doing many, many different things. So I saw lots of different architectures that we're using, either web, HTML, or RMI, or EJB. So
okay, and which server did you use?
In the servlet days, we would be using JRun, as was back in the Apache days, and then for EJB we used very, very early WebLogic 4.
Yeah, exactly. Even earlier there was a Tenga.
Yeah,
that was the name.
I didn't ever use Tenga, but I worked with WebLogic 4. So
okay, cool. And then, so what happened? Then we got Java 5 and Java 6 in one point of time. Somehow you stick to Glassfish, right?
Well, I briefly worked for Oracle for 2 years. So
I didn't know this.
I worked for Oracle 2000 to 2002, which is when they bought OC4J from a Swedish company, whose name I forget. And Orion, that's server, it. Right? Yep. So I worked with OC4J, and 2002 I left Oracle and basically became an independent consultant for doing a lot of work for BEA, and founded C2B2 in 2002.
But the OC4J was actually interesting. So I used the Orion server back then, and this was like built by a really small dedicated team from Sweden. And they had even, a deployment UI user interface, which was really lightweight, and it worked very well. It was very fast. So the startup was great. And then, the longer the longer Oracle, improved the product, the slower it became. But at the beginning, it was a really fast product. I really liked that. You used OC4J in some projects?
No, I was just there as an Oracle consultant, so we had to learn it because it was just at the time they bought it. So
okay, and you like that?
At the time, it was great when you first got it because you could just unzip it and run it.
Yeah, this was perfect. This was a really great technology. Yeah, this is. I was really. It's like this is really nice back then.
It wasn't so great when it became 9IS and it involved all the process manager and all that sort of stuff.
Yeah, exactly. This is usually beginning of the end. If you get more and more features, and then it begins to die. Okay, and you founded so C2B is your company, and this is fairly old company then, right? So 2002, there's 15 years. So you had a 15 years party right now.
Yeah, we've been going a long time. I mean, we mainly do consultancy, performance, scalability of Java EE application servers. Essentially, what the company was founded to do. We did a lot of subcontracting to BEA, subcontracting to Red Hat and JBoss 4, and onwards. And nowadays we tend to go direct to clients. So.
And how big is your company?
About 15 in C2B2.
Cool. So and then, this was your OC4J and Glassfish. So what was your first time with Glassfish?
So C2B2 were basically independent. So they provided support across WebLogic, Glassfish, JBoss. So we started doing probably consultancy in Glassfish. I can't remember when now, probably, 2010, maybe 12, something around that sort of time. Glassfish 3, really, we didn't have really a lot of Glassfish 2 experience. So once they re-architected it into Glassfish 3 is when we started looking at it and seeing more and more of it in the market and getting requests to do consultancy work on it.
So it's actually interesting that we never met each other because I did a lot of Glassfish work, and I started actually with Glassfish V2 and I think even V1, and V2 or was the Sun 1 something server, and I used Glassfish V2 in commercial projects, and then of course migrations to V3, which I remember. Then lots of memory leaks and stuff we had to do with V3, and then stick with Glassfish. And that's interesting. And then you started the Payara, which is like a spin-off, right, of the C2B2?
Yeah, so essentially what happened when Oracle stopped commercial support, we got asked by one of our consulting companies who was rolling out Glassfish 4 whether we could fix some bugs in the core application server. So obviously we're a consulting company, we'll do anything for money. So we basically fixed those bugs for them, and then they asked us how we were going to make sure those bugs could go upstream into the Glassfish code. And at the time we discussed with some people about getting it upstream, but it was quite difficult. So basically once you do updates to an open source project and you want to release your own version of it, for trademark reasons you have to rename it. So at that point we created Payara, and really just to support that initial customer. And then we launched Java 1 about a month later just to see what the interest would be. So we had a very, very small stand at Java 1, and we picked up a couple of customers at that point. So we thought, this is a good project. So we created a spin out within our organization and hired a engineering team. And that's where Payara came from. So basically, there was a desire in the market to keep it alive. There was a lot of fondness for Glassfish, so we supported that.
Okay, which year was it? 2010 or 9?
Now, when did Oracle? It'd be a year later than that. So 14 maybe.
This was later with 2014. Oh yeah, exactly, because Oracle acquired Sign in 2009 and 2014. This is exactly what was my when you invited me to the Java user group London, talking about Glassfish. This was 2014 in January.
Yeah, we had.
And I think
we had the Glassfish user group before we had Payara. So we were doing the Glassfish user group as part of C2B2, who still do the JBoss user group in London. so we were quite heavily in Glassfish at that point in time.
And what was the response to Payara, the first Java one? So were the clients, did you get lots of, interest, or was just, I don't know. So what happened actually at the booth at Java One in 2014?
A lot of people were really fond of it, and we had a lot of people come up to us and say, "Oh, it's fantastic what you guys are doing, but we don't use Glassfish, which we use Tomcat." But a lot of the ex-engineers as well came up to us and said, "This is a fantastic thing you're doing." But crucially for us, from a business perspective, 2 large US users came up to us and spoke to us about how they really, had just migrated to Glassfish 4, or they were on Glassfish 3. Both of them actually, interestingly, currently didn't have any support, but they really wanted some support. So they spoke to us, and they bought a very, very small initial contract to see how we got on, and then it grew from there, really.
And do you have any idea how many commits you already contributed upstream, or how many bugs are fixed around? So because if someone asks me now what is Payara, my answer is like patched Glassfish with commercial support, which is optional. This is my answer. I hope this is politically correct. But how many patches or bugs you already fixed? Do you have a rough number?
It'll be hundreds and hundreds now. How many of those we created ourselves nowadays, and how many are upstream, would be a number I wouldn't know. In the early days, we created lots of bug fixes.
What is the most crucial one? So I would say, okay, this is like, no-go for Glassfish, but really important for Payara clients, something like this?
One of the very, very early ones when we first got it was a major memory leak in the CDI layer, which basically made it very difficult to use in production. So
I think, was it around Christmas, the Glassfish distribution? Because I think we found the bug as well in a project, in a stress test. Was it? Do you have in memory? Was it around winter with the bug?
It would have been, but it'd been a couple of years ago.
Yeah. This was a V3.
Yeah, basically it came from C to B2. A consultant was in the field, helping a customer that had Glassfish, and they identified a major memory leak was the cause through a heap dump, and we fixed that for that customer.
And now, how Payara is doing? Do you have, is it growing? I just see that you are hired some support engineers, so you get lots of interest, client requests. So what's the business around Payara? Is doing well? Is interesting, or?
Payara is growing really quickly. It's an open source project, so there's always a challenge asking people to buy support contracts, and Payara is purely now funded from support. It's not funded by the consulting company, and it's actually getting to the point where it's a similar size to the consulting company. So we've got many new customers, and we're hiring people all over the world at the moment. So we've got customers in Japan, in the US, and Europe. So we've got them right around all time zones at the moment. So 2 priorities we've got. One is to build up the engineering team to meet the challenges of microprofile and E4J and standards work around that. At the same time, we've got a challenge to build up our support team so we can support people in 3 time zones around the world. So, but we're growing. We're still very small. I mean, we're probably about 15 to 20 people now. I tend to lose count, and so we're still small, but we're still funded purely by people who buy support services for us. So that funds all the open source work, all the E4J work, and microprofile work.
I actually do not believe in big companies, because usually one point of time is lots of overhead, management and politics. So being small is always a good thing, I guess. And this is actually interesting that it's doing well. So one question I have is, people are somehow associating, I don't know actually why, Java is heavyweight or not productive, or put any negative comment here. In my project, it's completely different. So people care less about Java EE. They would like to have solutions. And if I present them, some proof of concept with Java EE, they're actually delighted. And they ask me, what is it? I was like, okay, this is the application server called Java EE. And they say, okay, let's go, because it's extremely productive. So do you have any idea why your customers are using Java EE, and what is the response, to productivity, Payara, and the, let's say, development side of things?
So I would say most of them use Java EE because they've always used Java EE, and one of the major goals of us in Payara, because I've always used Java EE as well, is to take Java EE developers along to all the new architectures. So Java EE can be cloud native, Java EE can work on IoT, Java EE can be anywhere, any other server-side development can be. So the main reason would be they have a lot of experience. There's many Java EE developers out there. They may not, get the most visibility in the market because they don't shout too loud, because they're just building real systems. So that's why most customers, I would say, would be on it. But our goal as Payara, like I say, is to make sure that those myths about servers and application servers just aren't true. I mean, Java EE at the end of the day is an API that builds on a lot of runtime services. Those runtime services, as we've proven with Payara Micro, don't need to be heavyweight as such.
Yeah, actually, Payara never was.
No.
So the interesting part is, I'm back from the Ueaber JARs conference. It was last week. I also met, of course, Payara team there. And I delivered similar session what I did at Java 1, so the heavyweight versus lightweight, and I measure the whole session, the heap overhead. And the attendees were, they couldn't believe it. It's like, this is actually, it is unheard of that the application servers are so small. And the funny thing is, everyone bashes Java EE, but no one measures. And this is so simple to fire up, the JVisual VM or whatever tool you have, and just to see how much memory actually the application server consumes. And Payara was really small and lean with the default configuration. I just used the 473 and just launch it even with the standard -X MX 512.
Yep.
And it just consumed about around, I think, 60 megs or something like this. Deployed an app, performed some performance tests, and we hit 10K transactions per second with fully activated monitoring even. And I say, okay, what's the deal? What means lightweight? And this is actually undefined. The whole discussion about heavyweight and lightweight, I couldn't even tell you what it actually means. So where are I going? So I would say lightweight is like assembler applications, like kilobytes is really. And if we already start Java, then we are almost in the heavyweight,
we used to,
region.
We used to do an interesting thing as consultants. So we did a lot of performance stuff as a consultant company. And we used to work heavily on WebLogic. So one thing we used to do for customers who'd complain that WebLogic was bloated and making their applications really slow is we would basically write a servlet, deploy it, hit it really hard, and it would respond in like a couple of milliseconds, and then point to the customer that perhaps the reason that their application is responding in 5 seconds is slightly down to the application and how it's built, rather than the internals of the application server. And that little app we used to deploy would be a servlet doing JPA, inserting some into a database, coming back, just to prove that all layers actually were very fast and lightweight.
This is what I actually do right now, is with JARs, CDI, EJBs, and I do the heavyweight stuff with CDI, a couple layers of injection and even track, hit up the profiler and see what is actually the output. And this is the same. This is in a couple of milliseconds you get the answer. And I would even say that the most of the problems are I/O to database, not the most of the application services are not even the problem. The problem is usually the database. I don't know whether it's also your experience, but where I/O is involved, that there are problems.
Yeah, I mean, as like a middle tier engineer for all these years, you can scale the middle tier so it kills the database quite easily with application servers.
Exactly.
And then you need to work out with the database team to work out how you can work with them to make the middle tier not kill the database, which is a lot of what application servers do. They protect the database. They don't They're not just there for their own reasons. Most of them access databases and they're there to protect the
Exactly,
database.
and I remembered now something. The application servers, the early days, the killer use case was the database connection pooling, actually, because you needed less licenses to the database. So lots of my clients wanted to have application servers because the resource user was pooled. Remember these days?
Yeah, I mean that's an application server is an old TP monitor. Really, you're taking thousands of users and pushing them through 10 to 20 connections. That's what most people do use application servers for, and Java EE and that use case hasn't gone away, and you can do it in many different ways, but Java EE gives you a standard way of doing it.
Yeah, cool. So what always interested me actually, why you started with Payara Micro? Was it like a marketing gig, or what's the deal with that? Because the Payara was always small, so why Payara Micro?
Okay, Payara Micro was started not necessarily to be small, because like I say, it's actually this was the secret of it, is it's not that much smaller than the server itself.
Exactly.
The reason really was to move away from, well, there's two reasons. One is so it's an area we can experiment and innovate without breaking the server itself. So we could do things in Payara Micro which we probably can't do in the server, like the sort of auto clustering and things like that. So that was one reason. The second was to move away from the domain model. When you move into sort of cloud native architectures and things like that, then the domain model starts breaking down. So the domain model in an application server is where you have a fixed number of standalone servers controlled from an administration server. So when you move into cloud or Docker containers and things, that sort of goes away. If you need elastic scaling, then you need to not have a fixed set of servers. So Payara Micro is really created to start messing around with those sort of architectures and address those architectures. So it probably should have been called Payara Cloud Edition or something, but Micro was all the rage, and microservices terminology was out there from a marketing perspective, so it became Payara Micro. But really it is the area we're looking at elastic scaling and those sort of areas and architectures. The third reason was to actually make it very easy for new sort of beginners to use Java EE, and therefore the ability just to run a jar file, take a WAR file, and just run it from the command line. That again was there to make it very easy for people to use it for demos, or for new people to learn how to use an application server. So you don't have to work out what the password is to get in the administration console and work out how you deploy an application via the admin console.
This is actually true, right? So you can download the jar and say Java -jar, Payara Micro - deploy and war, and it runs. So this is beautiful, actually.
The only marketing feature in Payara Micro really is the creation of the Ueaber jar. Personally,
okay, I didn't want to mention this.
Personally, I see no point, but that's my personal opinion.
So I thought a lot, what would be the killer use case of the Payara Micro, and I actually and Ueaber jar, and I found hopefully something. So in some projects we need extensions of Java EE. I mean, extensions like domain extensions. So the perfect case is, for instance, POE library, the Apache POE, where you can write and read, Office documents from Microsoft, for instance. Yep. And in this particular case, what we usually did is we try, to move this out of the war, because in my world, thin wars is best practice. So if the war is thin, deployment is faster. So, and we use it, either we put it to layers, Docker layers, or Glassfish libxt, or in a lib folder. And with Payara Micro, you could actually create your own distribution of Payara Micro with the libraries required already inside the micro. So you could have your own company, micro distribution. And this, I think, is a valid use case, because I got lots of questions what we can do, with valid dependencies, not like, nice to have common something, but really stuff which we wouldn't like to reinvent. So I see actually this is as a killer use case. You also see this? Or?
Yeah, that's a fairly new feature, in that we have the add libs now, where you can add jars into the micro jar file, Ueaber jar, and we do see that now. People packaging up libraries and and place them within the jar files, then you have one unit. That's an evolution of where we were originally.
Yeah, perfect. But I agree fully with you that like Cloud Edition, but having said that, I always use Payara with a single domain for the cloud deployment, so I didn't need the domain server. We just used one server without clustering, and this worked well. But you are right. If you don't need it, so you can just remove it, and what remains is like a micro, right? Because you can simplify things.
Yeah, the only other difference is micro doesn't have OSGI, so it doesn't have the complexity of OSGI internally. But that's not really an advantage. It's just, but yeah, it was definitely for that cloud architectures, that sort of view of how to run multiple independent servers and to get them to cluster together. So you can do this in putting a DAS only; they can still cluster through Hazelcast.
So nice. So I think 2 years ago, you started the microprofile, Eclipse microprofile project, but it was not first Eclipse, it was just a microprofile website, and then they moved to Eclipse. So it started with a call, and then the project started, which was actually great because then you get room, to innovate. So what was the history of the microprofile? So this is Payara Micro is something like the implementation of the Eclipse microprofile, or what's the relation between Micro and Eclipse microprofile right now?
Okay, so the relation, there isn't one really, in that, so microprofile itself, we were invited by Red Hat, because Red Hat and IBM kicked off the initiative. So we got involved from the first day when it was announced. So microprofile itself is building sort of new APIs in a collaborative fashion, for microservices architectures. And Payara, so Payara, the company, are implementing those APIs, but those APIs will be available both in Payara Server and Payara Micro. So we're not restricting them just to the Micro edition. Mm-hmm. We're making them available because most of the capabilities offered by microprofile APIs are just as suited for any distributed application, whether it's microservices or not. So we're basically going to put APIs in both server and micro, so there'll be no difference in what APIs are available. It's really just the deployment model that changes between server and micro.
Okay. So what is actually the added value of Eclipse microprofile right now, comparing it to, let's say, stock Java 8?
So microprofile is adding new APIs. One for configuration, so you can inject via CDI config properties, so like environment variables, properties files, directly into your applications, which is very common need on a cloud architecture because you have a standard runtime, say like a Docker image, but then you take that runtime and run it in many different environments. So you can then basically inject what changes between those environments into your application. And we're building that into the server itself longer term so that you could be able to inject those properties into things like data sources, message-driven bean configuration, those sort of areas. Microprofile is also building APIs around standard sort of distributed computing things like bulkhead and circuit breakers, those sort of APIs too, for calling out to external services in a more robust fashion, and delivering health check and metrics APIs so we can integrate them more into cloud monitoring. Personally, I think microservices probably is a bit of a bad name because a lot of this is really cloud native. I think cloud native is more important than the microservices piece. So
yeah, for me, microservice doesn't mean anything. It's like, I always do the joke that actually all my talks were about microservices, but 5 years ago I had no idea that there is a name microservice. And because we always have to think, about timeouts, and we always had, bulkheads and thread pools and EJB pools even. So there was no difference to now, because the only difference is now people care about these things right now, and they will completely ignore back then. 5 years ago, or even more, created a monitoring solution for Glassfish, and this was very useful in my projects, but no one cares about this. It's like, okay, who cares about that? And now it would take off because everyone is interested in monitoring in dashboards and stuff like that.
Yeah, I think cloud native is the most important, which is actually being able to run within these cloud environments that are elastic, that are, that they can migrate things on the fly. Uh, Though that's building the application so it can live within that architecture, like on an Amazon or Azure or Google, is a challenge, and that's what we're addressing through microprofile, but we're also addressing it through the server modification to the server itself, core server and core microcode.
So the Payara full is also microprofile capable, right? Do I have also, okay, this is actually good to know, because I could use the Payara full with configuration injection, for instance.
Yes, we don't do microprofile 1.2 yet, because we're aligning that with a release that's based on GlassFish 5, but it will be there soon. But it will be on server or micro. It would make no difference.
Okay, cool. You said something interesting about Ueaber jars or fetch jars. I have to admit, I never got the concept. And I always ask developers why you are doing this. Because from the development perspective, it's like if you're building a business app, I would say only 2% of the whole runtime changes. This is your code. And with the Ueaber jar or fetch jar, you will have, to rebuild the jar each time. So you will build 98% of all the stuff which never changes. Also, in fact, your release cycle is, I think, 3 months, right? So every 3 months you would get a new release, right? So then it only change once every 3 months, but I will have to rebuild it over and over again. And I actually never got an answer. So I asked many developers, I even asked vendors at Devox, and I got one answer. One company told me, "You're right, but we started before Docker, and Docker solved the problem."
Yeah,
so this was for me.
I think that's the right answer. I think Docker solves that problem, and it's better not to have an Ueaber jar in a Docker because of the reason that you say. You don't want to rebuild the layer over and over and over again. The bigger the layer, the bigger pain that is. So the best Docker architecture would be, Payara server or Payara micro with a base layer, which is a solid version, and then adding your deployment unit on top.
Yeah, this is actually really funny because this is per accident, Java EE became the platform for cloud native, actually, right?
One thing we're seeing in the consulting side, the problem with Ueaber jars, which on a solid foundation, is that people don't know what's in it. So operations teams, when something like some vulnerability comes in some Apache Commons library, they actually have no idea whether any of their applications that are running as fat jars have that library within it, or it's very difficult to know that. Whereas if you have a versioned runtime, say a Payara Micro 17.3, then you can actually find out whether 17.3 is dependent on that or not. And obviously the same issue occurs if you package the world in your WAR file, but if you do thin wars, then you know what's in there.
Yeah, thin wars is the way to go, I would say. Also funny story. So I was hired for Java EE consulting, but it wasn't Java EE, and they used fetch jars. And the first day I just fire up Payara with NetBeans, and they say, "Why your deployment is so quick?" And I use Docker and a little bit of cloud. And I say, "Why quick? It's normal. This is nothing special." It's like, "What's in your case? Have you, is it a virus scanner? Why it's so slow?" And it turned out that they had to rebuild they did the Ueaber jar thing without recognizing this has nothing to do with Java EE. It was also not Payara. It was not Java EE. And this was funny. So my deployment took, I think, 2-3 seconds, and they're about 30 seconds. And then afterwards they say, okay, they thought that Java EE is heavyweight, and therefore they decided to go the Ueaber jar approach. So interesting. Okay, now we have E4J. So you are also a little bit involved in the E4J. Any thoughts on that? So is this good? Is it bad? So yeah.
Yeah. So I only heard about E4J at Java 1. So Payara are on the project management committee of Eclipse, which is like the top. Well, basically, our job is to help people contribute. So at the moment, nothing's really happening other than it's been all the announcements. So from my perspective, this is a good thing. Java EE so the JCP was slowing down, and really what we need to do is compete at open source speeds. So while maintaining a solid runtime that people can trust. So moving to Eclipse will allow a lot more contributions, and what I'd like to see is an open source sort of development process where basically contributions are king and anybody can contribute through Eclipse. And I'd quite like to see Java EE move to a more sort of time-boxed release periods. So whatever that period should be determined by the community, whether they want it fast or whether they want it slow. But essentially, we should have a release train where, say, every year there's a release. And I just made that time period up on the top of my head. And all the other individual specifications can move at their own pace, and then basically once a year you sweep up all the versions and the point versions and release that as a Java EE or EE4J release.
Any concerns with E4J or
concerns really is the volume of work that's involved. Ourselves and Tommy Tribe are in the PMC, but we are very small open source companies in comparison to the large organizations. And therefore, from our perspective, funds are tight. We are splitting our engineering into a sort of core server stream and a standard stream, which will cover microprofile and EE4J. But actually, the volume of work required is large. And I think that can be reduced if we go to an open source model. But the danger is there that the volume of work is just enough to swamp people.
I have another concern. So I look a little bit at the mailing lists and participated a bit, and I see over and over again like the modularization and runtime. So my concern is a bit, so far Java 7 was great because of productivity. So what I mean by that, so everyone could start quickly because you only needed one canonical dependency. This was the Java 7 API, and you were ready to go. So all the application servers I know are small enough that they can be used right away to develop, whether simplistic or complex business applications or applications. There are no more business applications, just applications. And what I'm a little bit afraid of, that we will get, huge amount of variations of Java EE just for fun. So like multiple modules, floating around. So I think the most important thing is to have still, the canonical EE4J full profile, whatever we will call it, which will include everything. And then if someone would like to, the BOM, the bill of materials, is everything there. And if someone would like to optimize, they can. They can create their own services, platforms, or whatever. But this is a little bit my concern, that if this becomes too complex, everything will die, because then Java EE is pointless.
Yeah, I agree with that. I mean, the modularity argument doesn't really switch me on, really, to be honest. Payara is modular. We could do a wildfire swarm style modularity, but we've not bothered doing the work because Payara micro is small anyway, and the actual gains. So we did for a while create a microprofile specific that only included microprofile APIs, but the boot time difference was half a second, and the memory footprint was like 10% difference. And the actual pain to modularize the whole of the application server so you can pick and choose pieces from an engineering perspective where we have limited resource was just not worth the effort. So we haven't gone the full wildfire swarm model, though we could. So I don't really see the benefit of modularization myself. The application servers don't start services they don't require. And they're all also very small. So I would fight against splitting Java EE into many, many different little profiles. I mean, the microprofile itself isn't really a profile. It's some new APIs. It's badly named, putting profile on the end of it. It's not like web profile or Java EE full. So I don't even see the point personally of the full profile of the web profile, but then I'm sort of a bit biased on that as well. So
this is exactly my opinion, but I think this is easier to implement servers, not to have to implement all the old stuff. I think this is the advantage to the vendors.
Now, I would like to see a legacy-free profile, or legacy-free where you're allowed to just remove CMP and IIOP
SOAP
and things like that.
And SOAP.
SOAP's an interesting one because that's sort of half in the JDK and half not. So it's difficult to know where that sits from a vendor's perspective. And SOAP's heavily used still. But I'd quite like to see, get rid of EGB 2.1, things like that.
So great. By the way, I remember the persistence technology. It was called Java Blend. You remember that?
I remember the name. I don't think I ever used it.
Blend. And it was in the parallel to JDO and CMP, which was really strange. And if you look at it right now, so you will find all documents. They look like JPA, and it was 99 or something like this. It's crazy.
Yeah, JDO is very like JPA as well.
Yeah. So perfect. Any things to cover? So, or do you have any questions?
No, I've enjoyed it.
Perfect. It was a nice conversation. Actually, we have no time if we meet each other. We meet at the booth or somewhere, and there is no time to speak. So I think the podcast is a great venue, to just chat about technical things. Where people can find you or Payara, or if they are interested in Payara or C2B2, how to find you on the internet.
Payara is at payara.fish, and C2B2 is at c2b2.co.uk. You can find everything about us there, about our support services and consulting services. So I'd encourage people to realize Payara is an open source company. That means we're only funded by support. So if you work for large organizations, please get them to purchase support. That's my plea.
Exactly.
So Payara follows a pure open source. So we don't have any freemium or any enterprise features that we hold back, and all development's done on GitHub. So we are a complete open source company.
Okay, perfect. So thank you. It was fun to me. So we can, repeat it if Payara 6 is out or something like this. So thank you.
No problem.
And see you next time, right?
Yep. Thanks. Bye.